going to be in a training video.
Okay. Hi, my name is Mark.
For other students around the state. All right, so my name's Rich Schrader.
Hi, Rich.
And I'm so glad to be working here with Escalante High on February 6th, 2013. Partnership with Trout Unlimited. This graphic, get close, get close. What is riparian? Right, you guys remember what the riparian area is in a river ecosystem? What part of the land is that?
The side.
Exactly, it's the banks and the vegetation on the side. It's the ecology of the forest, what we maybe would call the river forest. Now, when you study the health of the river, you cannot study it without looking at the riparian area, because the health of the forest on its banks dictates a lot about what's happening in the stream. And we've all looked at insects. Here's like an insect right here. This is the gut of a caddisfly, okay? The gut of the caddisfly has a front digester, a middle digester, and a hind digester, okay? And they are shredders. Many of them are shredders. So that means it's making its living. Its bread and butter, its food is coming off of leaves. Where does that energy come for to make the leaves in the trees? Where's the initial energy coming from to create those leaves? Ground, it's a combination of soil. What else?
Light.
That's the primary one. It's the part of the river, you're in a part of the river where the energy for the river system, the fish and the bugs, is coming from primary production, which is vegetation growth. You guys get that? Without vegetation growth, you have a completely different ecosystem. And that's going to be part of our point here. So the leaves fall. Look at the hole in this leaf right here. It's shredded. By that, it starts digesting that, and it gets converted into energy. What likes to eat caddisflies?
Fish.
Yeah, and crazy fishermen who like, caddisfly sushi. But if you look at this, it also creates a whole ecology. You've got all these different microbes living in it. And in fact, the actual microbes that live in these insects can help track the genetic flow, the geologic flow of the continents, because they have specific genetic markers. Like, for instance, South Africa, the bugs there have the same kind of genetics. The bugs and the bacteria in their bellies have the same genes as in Australia, because at one point it was Pangea. So that's interesting, a little factoid. But this riparian area does one other thing. Look at this tree, and it's growing by the bank. What else is it doing to the water? Besides growing the food that is the basis of the ecosystem, what else does the trees and the shrubs do next to the water? How is it changing the water?
Keeps some of the soil out.
Very good. It's preventing erosion. We talked about the roles of the willows and how they do that. But what else do they do? Where do you want to be on a super hot day?
Shade.
That's the biggest thing. It's the shade. So they are actually regulating the temperature. And one of the things I mentioned is that one of the problems in many of our rivers is too hot. Okay? So let's just say the riparian area is serving multiple functions. Just like, if you're president of the high school class, your function as president is multiple. Represent the school, raise money, build a float, whatever. Okay? Throw parties that are safe and fun. Riparian, these trees right here are serving that kind of function too. Erosion, temperature regulation, food, okay? You get it? That's why we look at the riparian areas, okay, when you're studying street. I wanted to show you this, and I'm going to give you a copy just so you can follow up on this in the future, okay? So, when we're looking at a riparian area, we want to look at lots of different parameters. I introduced this last time. So on the data recorder, I want you to start recording that. And we're going to try to get through as much as we can this year in this short field day. Look at okay, now let's start on this backside really quickly. One of the things you do on each riparian area is you delineate where you're going to be doing your study. I'll give you this to you too. The backside is the background information. You're going to want to do the same thing as chemistry, the weather, the date, what elevation you're at, an idea of the vegetation that you find here, what kind of trees, it could just be the names, and then what are the land uses in the river corridor. I'll quickly go through this option. Everybody pay close attention, and I want you to listen carefully and say, put an X next to the which one? Is it urban? No. Is it a roadless area? Okay, scattered residential? Maybe kind of, because they're going to have septic tanks here. They've got some.
Yeah.
They have to deal with scattered residential, so we can maybe check that one. And then, would you call it a recreational area or a high-use recreational area?
High use.
Okay, so I think let's go with that. Dispersed, scattered residential, or scattered, check that off. And then what you're going to want to do is make a hand-drawn map of the area, the best of your ability. And we're not going to have time to do that right now, okay? And then on that map, you indicate where the top of your reach is and the bottom of your reach. And usually you want to go ideally you're going about 200 meters or 600 feet. That really characterizes a reach, okay? Kind of depends on your questions, but it's good to be consistent, whatever your reach length is. Then you turn the page over and you look at the different parameters. And we already started some of this. We talked about this at our last field trip. And so what I want to do is, one, let's just first define where's the top of our reach. Where are we going to say the top of our reach? Something physical that you can find each time you come out here. Look upstream. What do you see that's pretty physical? So you have the dam, but that's too far probably.
The tree.
And you've got that tree. So we could start at that tree, or we could maybe, if we wanted to extend it out, we could go up to the bridge. Let's say, and then remember I 600 feet rule? How about from that bridge down to the bottom? That's maybe 2 football fields.
Sounds right, yeah.
Does that sound about good?
Yeah.
All right, so that's going to be our study site. And why don't we have each team focus on half of that? And let's say this tree is about halfway down. Okay, that's like our halfway point. How's that sound? Did everybody sound? So that's the kind of thing you'd write on your map. You write down your assumptions. You give an idea of the area, what your reaches and sub-reaches are. Because we have like basically 2 sub-reaches now, 1 for each team. Then you start going through this. So let's start doing it as we're walking downstream from that tree. Let's walk up here. And you can start thinking, look at your parameters and start thinking about how you're going to do that. Can you go grab that tape measure on top of my car? On that map, you can also put things like other places where you're monitoring. This is one of them where it's higher. You can always come back, come up on your own. The water's there. Okay, guys, so this is our starting point. Already, let's just get a name of the vegetation that we see. What is this?
A tree.
It's a juniper.
Type of tree.
What type of tree is this?
Chinese elm.
No.
Chinese elm.
It's a riparian plant related to the maple.
The maple's cousin.
And it grows bobs, like fishing bobs.
Yeah.
See?
Willow.
No, it's actually a box elder. It's
Oh, yeah.
Acer negundo.
Yeah, box.
All right, so and then we've got, remember, coyote willows downstream? So if somebody could write that down and the type of vegetation type, and I think our cottonwoods, we're not going to tell them easily, but I bet you we're narrow-leaf cottonwood country. It would be on the back. On the back, sorry. Yeah, when it says site vegetation, site description. All right, so let's see.